convex mirror, this one, and a concave mirror are placed on the same object axis, separated by the distance L equal to the 0.600 meter. The radius of the curvature of each mirror has the magnitude of the 0.360 meter. A light source is located at distance x here from the concave mirror as shown in the pictures. So what distance x will result in the rays from the source returning to the source after reflecting first from the convex mirror and then from the concave mirror. So let's see that if we have the light coming from the source here, right? So it just come to the convex mirror and then reflect the concave mirror and then go back to the source again. Okay, so it means that the final image will be on the same place as the original source here. So to solve for this one, we need to do the two steps in this case. The first one is we need to find the image due to this convex mirror, okay, and then after that the image of these convex mirrors will be the source of this concave mirror, and then we can find the position of the image from this concave mirror to be the same position as the original object here. Okay, so let's say that if we have the light, okay, coming from the source, okay, from the source, and then to the convex mirror, okay, then from this picture, right, you just see that the object distance here, okay, the object distance is going to be equal to the L and then minus the X. Okay, so let's say that the S equal to the L minus the X. So the S is to be the object distance. And now we just want to find the S palm. We just want to find the image distance, right? And then finally the focal length, okay, the focal length equal to. So it said that the radius of the curvature of each mirror has the magnitude of the 0.360 meter. Okay, so then it means that the magnitude of the R, for both mirrors here, is going to be equal to the 0.360 meter. Okay, so now for the F, right, because for the convex mirror here, for the convex mirror, the focal length must be negative. Okay, from the side convention, right, we said that for the focal length and the radius of the curvature, it should be negative when we have the virtual focal point. Okay, and this virtual focal point, is going to be on the opposite side as the reflected ray for the mirror here. So the focal point of this mirror is on the left hand side, but now the reflected ray is going to be on the right hand side because we have the light coming from the source, right, and it's going to reflect the mirror here. So the reflected ray is on the right hand side. Okay, so it means that this focal length must be negative. Then we have that the F equal to minus, right, the absolute value of the R and then over the 2. Okay, or just equal to minus 0.180 meter. Okay, because I just plug in this R into this equation, then we can get this one. And also for the S, right, it's just equal to the L 0.600 and minus the X. Okay, so now we can find the S palm. We can find the image distance, right, using 1 over S plus the 1 over the S palm equal to the 1 over the F. Let's use this one. Then we have the 1 over the L minus the X, right? Okay, so let me use this variable first, L minus the X. and then plus the 1 over the S palm equal to, so now we said that the F equal to the minus and absolute value of the R over 2, right? So it's just minus and 2 over absolute value of the R. Okay. So here we say that we just want to solve for the S palm, right? So okay, so let's move this term to the right hand side of the equation. We can get that equal to the 1 over the S palm equal to minus the 2 over the absolute value of the R, right? And then minus the 1 over the L minus the X equal to, okay, so let's cross this term, right, equal to minus 2 times the L minus the X here, okay, and then minus the absolute value of the R, and then over the absolute value of the R times the L minus the X. So then finally we can get that the image distance is going to be equal to the S palm, right? So just equal to minus sign. So let me just take this minus sign of this term, okay? So minus sign, and the absolute value of the R times the L minus the X, and then over the 2 times the L minus the X, and then plus the absolute value of the R. So this will be the position of the image, I mean from the convex mirror, okay. So now you see that the L minus X here is positive, right, because the L minus X is this distance, it's going to be the positive. So it means that this whole thing here is going to be the positive, but we have the minus sign here, so it means that totally it's going to be negative, okay, totally it's going to be negative. It means that the image is going to be behind the mirror, right, maybe somewhere here, okay, maybe somewhere here. So let me make the dots. So let's say that at this position, oops, no, okay. So now this one is going to be the image from the convex mirror, okay, it's going to be the image from the convex mirror here. Then so now this image will be the object for the concave mirror, okay. So now let's consider when the light just coming from the convex mirror and then go to the concave mirror, okay. So now from the convex to the concave mirror, let's just start from the S, okay, let's just start from the S here. The S is the object distance, so it's going to be this length, the object distance, okay. So we know that this length, okay, this length equal to the magnitude of the S palm, which is only for this term, okay, only this term. We not take into account the negative sign here, because negative sign just tell the direction of, I mean tell the position of the image, right, to be behind the lens, okay. But then the magnitude of the S palm just equal to this one. So here we can get that the object distance, right, for this concave mirror is going to be equal to the L and then plus the magnitude of the S palm here. So here we have that equal to the L and then plus the magnitude of the S palm, right, just this term, okay, just this term. So now for the S palm, the image distance, we need the image to be on this position, okay, which is equal to the X, right, from the convex from the vertex of the mirror here. So now the X, is it positive or negative, okay. So let's consider the sign convention. We say that if the image is on the same side as the reflected ray, okay, the reflected ray, So the S palm must be greater than 0. Okay, it's going to be the positive. Then in this case, you can see that the light, from the object here, right? So go to the convex mirror and then reflect it to the concave mirror and then just reflect back to form the image at this position. Okay, so now you can see that this light, okay, this light, it will behave as the incident light for this concave mirror here. So now this light, right, is on the left hand side of the concave mirror, and again this light will be the reflected light for the concave mirror, right, and this light is on the left hand side of the concave mirror as well. So then we can get that the image distance must be positive. Okay, then we have that the S palm equal to the X. And then finally for the focal length for the F, right, again the focal point is on the same side as the reflected light. Okay, so this will be the reflected light for the concave mirror, right? So the focal point is on the same side as the reflected light, so it means that the focal length must be positive as well. So here we have the F equal to the absolute value of the R and then over 2. Now let's try to relate these three variables together using this equation, right? So we have 1 over S plus the 1 over the S palm equal to the 1 over the F. Okay, so now let's just plug in the S palm and the F into these equations, right? We have 1 over, okay, so now for the S here equal to this term, plus the 1 over the S palm equal to the X equal to the 1 over the F, right? So we have the 2 and then over the absolute value of the R. Okay, so now you need to solve this equation to find the X, right? It's just quadratic equation. So the trick is that you just multiply this to this, right, and this going to flip to be the numerator. And then you have to have this cross term as well, and then you can just solve for the X here. Okay, so I will skip this algebra part here because it's too lengthy. Okay, so then finally we can get that the X equal to 0.240 meter and 0.720 meter. Okay, so we have the two solutions because this is just the quadratic equation. Okay, but now what is the correct answer? So let's see the pictures here. We say that the source is between the two mirrors here, right, and the L equal to the 0.600 meter. So it means that this X must be less than this L. Okay, then this is correct and the other one is wrong. Okay, because the X must be less than the L. Okay, so that's going to be our point.